All right, so um, here's an Euler's method example for this ODE. So dx dt equals x squared plus t, and we've been given this initial condition. I'm going to use step size 0.1. So first thing to do is translate our Euler method formula into the current coordinates and write down the derivative. Okay, so that's our formula that we're going to be working with, and now we just start constructing our table. So at n 0, t and x n at t 0. So we're starting at time 0. X is 0.5. So at n equals 1, we move to 0.1. And our x1 is equal to x0 plus delta t, x0 squared plus t0. And that is equal to, well, x0 is 0.5, dt is 0.1, 0.5 squared is 0.25 plus 0. We stick all that into our calculator, and we find that this is 0.525. Okay, so all right, so that's in red is just the actual calculation that you have to do. Second step, x2 equals x1 plus and that's equal to now, I'll just write it up here, 0.525 plus 0.1 times 0.525 squared plus 0.2. And that works out to be, when you stick it in your calculator, 0.5626. Now, incidentally, when I say stick it in your calculator, I'm actually doing this using MATLAB. I've output my results to a screen already, and I'm just reading it off. You'll note, however, that I've actually included a lot more decimal points than I'm writing down. So if I were to look at this one, for example, it's actually 0.5625 625. Okay, so doing this is going to introduce a round off error into the calculation. So this is what I'm actually using. Oops, wrong color. I'm using this higher precision to work out these numbers, but if you keep using this rounded off version, you're going to introduce a small error into your calculation. Now, I guess for the most part, that's okay in terms of a test. You're not going to be computing these things very far, but in terms of practical applications, that can be a serious problem. Just for completeness, I'll do the third step. I'll just tell you what it works out to be. 0.6142106640625. Right. There are a whole bunch of trailing zeros, which I've just omitted. So this is obviously getting to the precision level of my computer. But if you're looking at just the first 3 decimal places, obviously that truncation error is going to introduce problems as you go along. Right, so be mindful of that. If you are doing this on your calculator, try and maintain, like, use the memory functions to save your previous x value and use that in subsequent calculations for the most accurate results.